Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about solving equations, part 1. And here, the question we ask ourselves is, what value of x will make this equation true? And one of the strategies that students like to use is they like to use the guess and check method, and they just basically try different numbers in for x just to see what will work. So for example, students may say, okay, well let's try 6 for x. So 3 times 6 is 18, plus 4 is 22, and then they say, okay, well, x can't be equal to 6 because that expression would not be equal to 28. And then they'll keep guessing numbers until they come up with an answer. And most students can guess pretty well on the types of numbers you can get if the answers come out to be whole numbers. So like here, most students could probably be able to say, okay, it's going to be 8 times 3 plus 4 is going to be equal to 28, Mr. Roman, so that they say, okay, x is equal to 8. But we need a more systematic approach to solving equations rather than just saying, oh, well, let's just guess and check. And the way that we're going to learn today in class to deal with these kinds of equations where you only have a variable in one place is to work backward of the order of operations. So let's imagine for a moment here that we had this expression, 3x plus 4. The order of operations would have us start with the multiplication here as the first thing, and then we would add the 4. That would be the second thing. Now, if we're solving the equation for x, we're going to literally work backward of the order of operations. So we're going to start here with this and then move to this. And we're going to work backwards by doing the opposite operations. So here, if we start backward of the order of operations and use the opposite operation, we're going to subtract 4 first. Subtract 4. And whatever we do to one side of the equation, we have to do to the other side of the equation. That's a rule of equations. And so here, 4 minus 4 is going to equal 0. So we're going to be left with 3x on the left side equals 24. And then the order of operations next would say, okay, now instead of multiplying the 3 and the x, to undo that operation, you're going to want to divide by 3 on both sides. So that x we can see is 24 divided by 3, which is 8. And that matches what we originally thought the answer should be. Now again, the guess and check method is an okay method, but for an equation like this, 9x minus 2.5 equals negative 4.3, it's going to be pretty tough for you to guess and check what the answer is for x. So we need to use that systematic approach again. And you know, using the order of operations, we would start like this. We would say 9 times whatever number x is, then subtract the 2.5. But if we're solving the equation, we're going to work backward again. And so here, we would start with this number. And the way to undo the subtraction by 2.5 would be then to add 2.5 to both sides. Oop. So we would add 2.5 to both sides. And then here, we could say that negative 4.3 plus 2.5 would be negative 1.8. And then again, we're going to work backwards of the order of operations. So if we're multiplying 9 times x, to undo that operation to x, we would then divide by 9 on both sides. And here, you're going to say that x is equal to negative 0.2. Oop. So negative 0.2. Or if you wanted to write that as a fraction, you could say negative 1/5 for x. Now let's look at another type of example. Here, if we're looking at this equation, if we were going to use the order of operations for just a moment, and we would start, remember there's an imaginary set of parentheses here that groups the whole top part of this together. And the order of operations would say to start here with 5 times x, then subtract the 8, and then divide by the 4. Now, if we're working backward of the order of operations to solve the equation, we would then start with the multiplication of the 4. So if we're dividing by 4, then we're going to multiply by 4 on both sides. Okay? So on the left side, the 4's will cross-divide to give me 1. And on the right side, we're going to get 12. So on the left side, we'd be left with 5x minus 8 equals 12. And then we would work with the negative 8, so we would add 8 to both sides. So that 5x equals 20. And then we would do the opposite operation of multiplying by 5, which would then divide by 5, and then x is going to be equal to 4 in this case. So again, let's see another example like that. We would take here, we would start with the last thing of the order of operations. So the last thing that we do in the order of operations would be divide by 9. The second thing was add the 3, and the first thing was the 4x. So again, if we're working to solve this equation, we're working backward of the order of operations. So you want to multiply by 9 on both sides. And then you're left with 4x plus 3 equals 18. The 9's here cross divide to 1. And then we're going to subtract 3 from both sides. So 4x equals 15. And then we're going to take and divide by 4 on both sides. So that x equals 4 goes into 15 3 times as a whole number, but then it has 3/4 left over. And then you could also write this as a decimal as 3.75. Okay. Now let's look at this type of example. Here, the order of operations would say to start with division, so x divided by 9, and then it would say to add the 2. Well, if we're solving the equation, we're going to work backwards of that. So we're going to start with subtracting 2 from both sides, leaving us with x divided by 9 on the left side, and then 2 on the right side. And then here, if we want to undo the division by 9, we're going to multiply both sides by 9. The 9's on the left side will cross divide to 1, and you'll be left with x equals 18 in this case. And the last example, again, we're going to start by adding 3.1 to both sides. And then we're left with x over 5, or x divided by 5, is equal to 8.2. And then, to continue, if we take x and divide by 5, to undo that, we need to multiply by 5. And the 5's will cross divide. And I'm going to say that x is going to be equal to 41 in this case. So stay tuned for Solving Equations video part 2 to see what happens when you have variables, more than one variable in the equation, and variables on both sides of the equation.